Space is silent, but not empty. For centuries, Mars has glowed red in our night sky, a promise, a warning, a question. It's close enough to touch with our imagination, yet distant enough to hide its secrets. We've sent rovers, orbiters, and even our hopes there. But every answer Mars gives us only deepens the mystery. Tonight, we peel back the dust, the data, and the decades of denial to uncover the terrifying, fascinating truth. Mars might not be as dead as we think. In the summer of 1976, two robotic emissaries from Earth descended through the thin, rust-colored skies of Mars. Viking 1 and Viking 2, NASA's proudest creations, landed softly on alien soil, surrounded by a world that had fascinated humanity for centuries. The red planet had long been a symbol of mystery and potential. Now, for the first time, we were there, equipped with instruments capable of answering one of the oldest questions in science: are we alone? Among those instruments was one of the boldest experiments ever conceived, a biological test called the Labeled Release Experiment, designed by scientist Gilbert Levin. His idea was simple but revolutionary. If Martian soil contained living microorganisms, they would metabolize a nutrient mixture tagged with radioactive carbon. The detectors would then pick up a telltale gas, the unmistakable sign of life's breath. When the Viking landers performed the experiment, something extraordinary happened. The sensors came alive almost instantly. Radioactive carbon dioxide began to appear, as if something microscopic within that red dust was consuming the nutrients and exhaling. To confirm, NASA scientists heated another soil sample to sterilize it and ran the test again. This time, nothing happened. The life had vanished. By every measure, the first test had responded like living organisms would. For a moment, it seemed humanity had made the most important discovery in history, that we were not alone in the universe. But almost as quickly, excitement turned to doubt. Another Viking instrument, a gas chromatograph mass spectrometer, found no organic molecules in the Martian soil. Without organics, NASA reasoned, life was impossible. They decided the results were due to strange chemical reactions, not biology. Overnight, the discovery of life on Mars became an embarrassing false alarm. Officially, Mars was declared barren. Unofficially, however, Gilbert Levin never stopped believing his experiment had found something alive. For decades, he argued that NASA had made a grave mistake, that Viking had indeed discovered life, but our methods had unknowingly killed it. Years later, new evidence began to support Levin's haunting suspicion. In 2008, NASA's Phoenix mission detected perchlorates in the Martian soil, highly reactive salts that destroy organic matter when heated. This meant that when Viking's instruments had searched for organics by incinerating their samples, they may have unknowingly obliterated the very molecules they were looking for. In other words, Viking didn't fail to find organic matter, it burned it away. The lack of organics wasn't a sign of lifelessness, it was a tragic artifact of the experiment itself. Modern rovers have deepened the mystery even further. Curiosity has detected organic compounds at Gale Crater. Perseverance has done the same in Jezero Crater. What once seemed impossible now appears plausible, that the Viking landers may have truly encountered Martian microbes, fragile organisms that reacted briefly before being destroyed by our tests. If so, then humanity's first discovery of extraterrestrial life didn't happen in some far-off future, but nearly 50 years ago, and ended in silence. It's a sobering thought. Imagine microscopic life forms, dormant beneath the Martian dust for eons, suddenly stirred by a few drops of nutrient solution from a machine built by another world. For a fleeting moment, they awaken, metabolize, breathe, and then the chamber warms as part of the experiment's control phase. Within seconds, they are gone, the first encounter between two worlds, ending in the death of one. If Levin's interpretation is correct, then our history books are wrong. The first contact has already happened. We simply didn't recognize it. The Viking mission's legacy is therefore bittersweet, A triumph of technology, but a tragedy of understanding. It reminds us how fragile discovery can be and how easily the truth can be lost in our assumptions. Today, NASA's Perseverance rover drills into Martian rocks with tools far more precise, cautious, and aware of past mistakes. Future missions like the ExoMars rover and the Mars Sample Return Project are designed with contamination protocols that prevent both Earth microbes from invading Mars and Martian samples from being destroyed on Earth. These missions may finally settle the question Levin asked so long ago. And if, one day, we find undeniable proof of microbial life preserved in Martian soil, the world will celebrate, but it will also grieve. Because that proof will reveal something quietly tragic, that we met our cosmic neighbors nearly half a century ago and we accidentally destroyed them before we knew they were there. Mars, the silent planet, may have whispered the answer once already. We just weren't ready to listen. For decades, scientists believed Mars was bone dry, a frozen desert under an alien sun. The ancient river valleys carved into its surface told a story of water long vanished, of a planet that had once known oceans and rain but had lost them billions of years ago. Then, in 2018, a discovery stunned the scientific world. Deep beneath the planet's southern ice cap, the European Space Agency's Mars Express orbiter detected something no one expected to find what appeared to be a lake, still liquid, still there, hiding under 1.5 kilometers of solid ice. The discovery came from a radar instrument called MARSIS, the Mars Advanced Radar for Subsurface and Ionospheric Sounding. As the spacecraft passed over the Martian South Pole, it sent radio waves downward, watching how they bounced back from layers beneath the ice. Most reflections were weak or diffused, what you'd expect from rock or frozen water, but one region, about 20 kilometers across, gleamed in the radar data like a mirror. The signal was so bright and sharp that researchers compared it to the reflection seen from subglacial lakes beneath Antarctica on Earth. Their conclusion was extraordinary. There might still be liquid water on Mars. For life as we know it, water is everything. Where there's water, there's chemistry and the potential for biology. But how could a lake exist on a planet where the surface temperature rarely rises above -60 degrees Celsius? The answer might lie in the strange properties of brine salt water so dense that it can remain liquid far below freezing. On Earth, such brines exist in some of the most extreme places imaginable beneath Antarctic glaciers, in the salty basins of the Atacama Desert, and deep underground. Microbes have been found living even there, in complete darkness, surviving by feeding on chemical energy instead of sunlight. If the same kind of environment exists under Mars's ice, it could be a hidden refuge for microbial life, a biological time capsule from a wetter, warmer era billions of years ago. But not everyone was convinced. Almost immediately, skeptics began to question the finding. Some argued that the radar reflections weren't from water at all, but from layers of clay or frozen salts that can mimic the same bright signal. Others pointed out that the extreme cold near the Martian poles would make liquid water nearly impossible even with high salt concentrations. The temperature was still too low for any known liquid to survive. More recent studies have suggested that Mars may not have one large lake, but several smaller patches of briny sludge, perhaps mixed with mud and minerals. In other words, the lake might not be a true body of water, but a network of salty, half-frozen pools, still fascinating but less dramatic. Yet, even if it isn't a vast underground sea, the implications remain incredible. If briny liquid exists anywhere on Mars today, it means the planet's hydrological cycle isn't completely dead. It means that beneath that frozen surface, Mars still moves, still flows, still changes. It's a world in slow motion, a planet whose heartbeat has weakened, but not stopped. And there's another reason this discovery matters. These underground zones, whether they hold water or brine, could serve as natural shelters from radiation, from cold, from the ravages of time. To future explorers, they might be sanctuaries. To native life, they could be hiding places. A thin film of liquid beneath kilometers of ice could be enough to sustain microbial ecosystems, isolated for eons, evolving in darkness. Future missions are being designed with these possibilities in mind. Orbiters are refining their radar maps of Mars's poles. Ground-penetrating sensors and cryobots' robotic probes capable of drilling through thick ice are being conceptualized to one day descend into these frozen reservoirs. The idea of a robot melting its way through the ice, breaking through into a hidden Martian lake, and capturing the first images of alien microbes swimming in the darkness, it sounds like science fiction. Yet for the first time, it feels almost within reach. If water truly lingers beneath the Martian ice, then Mars has not finished its story. The planet that once flowed with rivers and oceans may still be alive in secret, hiding its final traces of habitability beneath the cold silence of its poles. We've always looked at Mars as a relic, a dead world frozen in time. But what if it's only sleeping? What if beneath the crushing ice lies something ancient and waiting, a remnant of a time when Mars was blue instead of red? The answer may lie in those hidden lakes, shimmering in radar echoes, whispering to us from the deep. The universe rarely buries its secrets without reason. Mars might just be keeping its most precious one a secret ocean, where the ghost of life may still move unseen beneath the frozen veil of an alien world. For years, Mars was thought to be silent, a dead world where nothing stirred. But then, one molecule began to whisper a different story: methane. On Earth, methane means life. It seeps from wetlands, from decay, from living things that breathe and die. So when scientists found methane on Mars, the question struck like lightning: what's making it? Methane shouldn't survive long under Mars' thin, irradiated sky. Ultraviolet light tears it apart within centuries, sometimes even faster. That means if we detect it now, something must be creating it right now. Early telescopes caught faint hints in the 2000s. But when NASA's Curiosity rover began sniffing the Martian air in 2012, things got strange. Methane levels spiked, then dropped, rising and falling with the seasons, like a planet breathing in its sleep. Was something beneath the surface alive, waking with the warmth and falling silent in the cold? But the deeper scientists looked, the stranger it got. While Curiosity detected bursts of methane from the ground, orbiters high above saw nothing at all. Two of humanity's most precise instruments staring at the same planet were seeing two different worlds. Theories multiplied. Maybe deep underground, Mars still holds chemical life, not biological but geological. Reactions between water and rock could release methane the same way Earth's volcanoes do. Or maybe the gas is trapped in icy cages, clathrates that thaw in summer and refreeze in winter, releasing brief, ghostly breaths. And then there's the most haunting idea of all, that something living is still there. Microbes buried deep below, shielded from radiation, feeding off minerals and hydrogen, quietly exhaling methane as they cling to survival. But if methane is real, why does it vanish so fast? Some believe Mars itself destroys it, its soil packed with oxidizing chemicals that devour the gas before it spreads. Others think the atmosphere traps it in invisible pockets that drift and disappear before orbiters can see them. Whatever the answer, one thing is clear: Mars isn't dead. It's active, changing, breathing. Each faint whiff of methane feels like a heartbeat, irregular, fragile, but alive. It may not prove life, but it proves something almost as profound: that Mars still remembers how to move, how to react, how to whisper across the void that it was never truly still. In 1984, a team of scientists exploring the frozen expanse of Antarctica stumbled upon a rock unlike any other. It was small, about the size of a fist, dark, heavy, and scarred by its fiery descent through Earth's atmosphere. They cataloged it as ALH 84001, one of many meteorites retrieved from the icy plains. But years later, this unassuming fragment would ignite one of the most controversial debates in the history of science because it didn't come from Earth at all. It came from Mars. Chemical analysis revealed that the gases trapped inside the rock perfectly matched the composition of the Martian atmosphere measured by the Viking landers. That alone was astonishing proof that rocks from Mars could reach Earth, blasted off the planet's surface by ancient impacts and drifting through space for millions of years before falling onto our world. But what truly shocked the world came in 1996, when NASA scientists studying the meteorite announced something extraordinary. Within its structure, under an electron microscope, they found microscopic shapes, tiny, worm-like patterns that looked eerily similar to fossilized bacteria. The headline spread like wildfire: evidence of life on Mars. For a brief moment, humanity believed we had found proof that life once existed on another planet. Even the President of the United States addressed the nation, declaring that this discovery might change the course of human history. But science, as always, demands skepticism. As other researchers examined the sample, doubts grew. Those tiny shapes could be formed by natural chemical processes. The minerals surrounding them, magnetite crystals, might arise from geological reactions, not biology. The organic compounds inside could have been contaminated after the meteorite landed on Earth. Slowly, excitement turned to caution, and caution to disbelief. Yet, the mystery refused to die. Even if the shapes weren't fossils, the meteorite still contained undeniable signs of complex chemistry, the kind of reactions that precede life. And more intriguingly, it showed that Mars once had conditions warm and wet enough for biological activity to exist. In a way, ALH 84001 still carried a message from the deep past of Mars. Life might not have formed there, but it could have. Today, scientists no longer claim that the rock contains Martian fossils, but they still study it as a relic of ancient potential. It's a piece of Mars we can hold in our hands, a messenger from another world, telling us that the boundaries between planets are not as absolute as we once thought. Meteorites like this remind us that the ingredients of life can travel between worlds, perhaps even seeding one with the building blocks of another. Whether or not ALH 84001 truly carried fossils doesn't change its importance. It stands as a symbol of how close we might already have come to discovering life and how fragile that discovery can be. A rock that fell quietly into the snow of Antarctica might still hold the first whisper of Martian biology, and if it doesn't, there will be others like it, waiting somewhere out there, drifting through space, carrying the history of a planet that refuses to be forgotten. For most of human history, Mars has been the planet of dust and silence, a cold, dim world circling the sun in lonely stillness. But in 2014, something strange began to shimmer above that frozen landscape. Astronomers studying images from Mars' orbit reported seeing a glow, a faint, greenish veil flickering near the planet's poles, and sometimes spreading across its horizon like ghostly light. It wasn't sunlight reflected off the surface, nor the glint of dust. It was something happening in the atmosphere itself. On Earth, we know such lights well. They're auroras, born when charged particles from the sun slam into our magnetic field and ignite the air in dancing colors. But Mars is different. Long ago, the planet lost most of its magnetic field. Without it, the solar wind blasts directly against its atmosphere, stripping it away molecule by molecule. So how could Mars, nearly defenseless, still produce such a glow? The answer came from NASA's MAVEN orbiter, the Mars Atmosphere and Volatile Evolution mission. MAVEN detected charged particles funneled into the planet's thin atmosphere by patches of crust that still hold faint traces of magnetism, remnants of the global field that once protected Mars billions of years ago. When the solar wind interacts with these magnetic fossils, it creates small, localized auroras, bursts of green and ultraviolet light that ripple invisibly across the Martian sky. But the mystery didn't end there. In 2020, scientists discovered another kind of glow, a bright night glow produced not by solar storms, but by the planet itself. High in the atmosphere, carbon dioxide molecules break apart in sunlight and recombine at night, releasing faint green light in the process. This glow pulses with the Martian seasons, waxing and fading as the planet tilts toward and away from the sun. It's a kind of breath, the planet exhaling light into the darkness. From the surface, these glows would appear as gentle curtains on the horizon, too faint for human eyes to see, but radiant through ultraviolet sensors. They remind us that Mars is not as lifeless as it seems. Its skies are dynamic, alive with invisible movement, a whisper of the power that once protected it, and a sign of the forces still shaping it today. There's a kind of poetry in that, a dead world that still shines, even faintly, under the touch of the Sunday. Every flicker of light above Mars tells a deeper story of what was lost, what remains, and how even a dying planet refuses to go dark. The red planet may be silent, but sometimes, in the void above its horizon, it still glows softly, defiantly, as if remembering the warmth it once knew. When we picture Mars, we imagine a world of open plains and rocky craters, a desolate surface battered by storms and cosmic radiation. But what if the most important secrets of the planet aren't out in the open at all? What if they're hidden below? High-resolution images from orbiters like NASA's Mars Reconnaissance Orbiter, MRO, have revealed something astonishing. Holes in the Martian surface, deep, circular pits that seem to plunge into total darkness. Some of these openings are perfectly round, surrounded by the collapsed edges of ancient lava tubes. Others sit near extinct volcanoes, hinting that Mars once flowed with molten fire. These aren't just geological curiosities. Scientists now believe these caves could be the most promising hiding places for life on Mars today. Unlike the surface, which is blasted daily by radiation and temperature extremes, the interior of these lava tubes could offer protection. Inside, the temperature might remain stable cold, but not deadly. Radiation would be almost entirely blocked. And if any traces of underground ice or geothermal warmth still exist, these caverns might provide the last refuge for microbial life, quietly surviving far beneath the surface. Exploring these places, however, is another challenge entirely. They're too deep and too dangerous for current rovers, whose wheels and sensors aren't built to descend into pits or navigate uneven floors. So, engineers are designing a new generation of robotic explorers, spider-like drones, climbing robots, and autonomous hoppers capable of diving into darkness where no sunlight reaches. NASA's Braille and Moon diver concepts, along with the ExoFly drone prototypes, are paving the way for missions that can explore underground environments not just on Mars, but on the Moon and beyond. What might we find inside those caverns? Possibly frozen water, ancient mineral deposits, or even chemical traces of biological activity, carbon compounds, methane leaks, or fossilized microbial mats clinging to the walls. In a way, Mars caves are like time capsules. They could preserve the chemistry of a younger planet, one that once had rivers, lakes, and a thicker atmosphere. And if there is life on Mars, even the simplest microbial kind, the caves are where it would most likely be hiding. Sheltered from the deadly sunlight, feeding off mineral energy or faint traces of moisture, such life would be quiet, slow, and almost invisible, but alive nonetheless. For future human explorers, these caves could also become shelters, natural bases, protected from radiation, dust storms, and freezing nights. One day, astronauts might walk through the entrances of these alien caverns, their lights cutting through the darkness, and see something that has never been seen before, proof that Mars still breathes in secret. Until then, the caves remain silent, vast, untouched worlds within a world. But every shadow, every hole in the red dust could be a doorway to Mars' most ancient story, and perhaps its most living one. Mars may look calm from afar, a quiet, rust-colored orb drifting through the void, but up close, it's a world of chaos. Every few years, the planet is swallowed by storms so massive they can be seen from Earth through a telescope. They start as small, swirling clouds of dust, barely a ripple across the surface, and then grow, merging, expanding, until they blanket the entire planet in a choking red haze. When that happens, Mars disappears beneath its own atmosphere. The sun vanishes. Day turns to a permanent, dim orange twilight. And the storm can last not for hours or days, but for months. These are not storms like anything we know on Earth. Mars's atmosphere is 100 times thinner than ours, too weak for hurricane winds or thunderclouds. But what it lacks in density, it makes up for in scale. Even a gentle breeze on Mars can lift fine grains of dust high into the sky, where they remain suspended for weeks. Each particle reflects sunlight and traps heat, creating a runaway effect. The warmer the air becomes, the more dust it lifts, feeding the storm in an endless cycle until half the planet is consumed. NASA's Mars Reconnaissance Orbiter and the Perseverance rover have watched these storms unfold in stunning detail. What begins as a faint veil in one hemisphere can grow into a monster, a swirling, planet-sized engine powered by sunlight and dust. Temperatures fluctuate wildly. Winds can reach speeds of 100 kilometers per hour, not enough to knock over a person, but strong enough to sandblast metal and wear down machinery. In 2018, one such storm spelled the end for the Opportunity rover. It had been exploring Mars for 15 years, far beyond its expected lifespan, when a global storm rose without warning. Dust filled the sky, blocking out nearly all sunlight. Opportunity's solar panels starved, its batteries drained, and the rover entered sleep mode, waiting for light that never returned. When the storm finally cleared months later, Opportunity was silent. Its final message to Earth, translated from telemetry, was heartbreaking. My battery is low, and it's getting dark. For scientists, these storms are more than obstacles. They're mysteries of planetary physics. What triggers them? Why do some grow global while others fade away? Mars's thin air and dusty surface interact in complex, unpredictable ways that we still don't fully understand. Even now, researchers study how electrostatic charges might build up during storms powerful enough to create lightning-like discharges or strange glowing phenomena in the atmosphere. And for future astronauts, these storms will be among the greatest challenges of all, not because of their wind, but their darkness. For months at a time, solar power could vanish. Navigation systems might fail. Communication with Earth could weaken as static fills the sky. The very air would shimmer with suspended dust fine enough to infiltrate machinery, seals, even lungs. Mars's storms are both beautiful and terrifying, a reminder that even a dead world can rage with power. When we finally walk there, we'll do so knowing that the ground beneath us is ancient and silent, but the sky above is alive, shifting, and waiting to wake again. Because on Mars, it's not the thunder that kills, it's the silence after the storm. And that's all about Mars. If you enjoyed learning something new and want to explore more amazing facts about space and our universe, don't forget to like, subscribe, and tap the bell icon so you never miss a new video. Thanks for watching, and I'll see you in the next one, where we keep exploring the wonders of space together.